Hello everyone. The stable marriage problem is one of the interesting application using the bipartite matching. The bipartite matching criteria is no two edges can share the single vertex. Okay, you see the one is sharing only the single vertex, right? The two is also connecting with only single vertex. If you connect n with the two, so here two edges are sharing the vertex 2, so then it is not a bipartite matching. Using this criteria we are going to apply the stable marriage problem. The stable marriage in the sense here the man, any man should match with single women, right? And any women should match with single man. That is the criteria here. So based upon that we are having the subset y which is having n number of boys, and subset x is having n number of girls. Here each girl is has having her own ranking list, like that each boy is also having his own ranking list of women. So for example, in Indian culture, from the bride or bridegroom's family, we will use it to use the horoscope for identifying the matching by using moon stars or sun stars. Okay, so sun signs are moon signs. So here based upon that matching, we will sell you assume the bridegroom received 5 horoscopes. Okay, so from this 5 horoscopes he identified all are suitable for his marriage. Okay, then if all 5 horoscopes are matching, then he will give some ranking based upon the girl's academic background and girl's family wealth background, and girls are having siblings or not, and is that girl is working or not, and if she is working, what is the salary. So those details will be used to give the ranking. If any girl is having a high salary and more background, then they will give first preference for getting the matching from the boys home. Okay, so like that women also have same ranking of factors. If she is receiving 5 horoscopes from the matrimonial broker, then she also will check the salary of the boy, family background of the boy, that boy is having a own house, four wheeler, like that. So based upon that she also will give some ranking to that 5 persons, who is in the first rank, who is the second preference, who is the third preference, like that. So here ranking list will be used by boys home and also girls home separately based upon this different features in real time. So like that in programming also we are going to use ranking list for the men and women. Here the marriage matching is represented as a m, which is having set of pairs. Okay, that means man and women. A pair man and women is said to be blocking pair for matching m if that man m is not matched with women w. That means blocking pair means still they didn't get any marriage proposal or marriage matching. Okay, but here they can prefer each other to their mates. That means even though they are not matching, for example, here you see one is got matched with not married, just matching with the two, right? And the second person is matching with the first person, but n is not at all matched with anyone in the man group, and also in the girls group also n is not matched, then it is called blocking pair. Even though it is not matching with anyone, n can be and n can select anyone from this list, right? Anyone from this list based upon this given factors. Okay, so that is called blocking pair. If marriage matching m is called stable when the no blocking pair is available. Okay, if everyone is blocked, if everyone is matched, then that is called stable marriage matching. If anyone is not matched, as of now you see n is not matched, okay, then it is called unstable marriage matching. So we have to identify the stable marriage matching by using the bipartite graph matching. Okay, that is the problem statement here. So based upon that, algorithm is given, start with all the men and women being free. Initially we are assuming that all men in the man's group and all women, right, in the women group, all right, all are free, no matching is done as of now. Then when they are free, right, we are making the men oriented proposal here. Men will propose to the girls. That means men will send the marriage proposal, that horoscope, to the women's family, right? So arbitrarily select one of them, right? So men will select arbitrarily one of them and apply the following steps. So the man is selecting when the man is selecting the women, then he is uh, proposes, right, he is proposing to that woman. That means they are sending the horoscope to the women's home, then the next woman on his preference list. Okay, so you see, he is having, right, he is having three options, but he is randomly selected, right? Now the woman is checking, is she free? If she is free, without checking anything, they will accept. For example, in real time, if girls are waiting for long time for getting matching, then they will accept without checking any other background, I mean any other more number of criterias. Okay, they will accept that with minimum criterias. So here, if she is free, as of now she is free, so she has to accept the proposal with that man M. But when she is not free, then what will happen? Suppose if women already received some marriage proposal and they chosen that candidate as a I mean selected person, then what will happen? Suppose you assume that first proposal is selected with salary is 50K, right? Then second proposal is coming from the man too. If salary is 1 lakh, then what will happen? That women, they will compare the salary of this both persons, this already selected proposal, but now the new proposal is man too. Okay, so when new proposal is coming, that girl will compare that two persons. Then here, if she preferring, okay, if she prefers the new proposal based upon the salary, then she will accept the for second person. Okay, then that farmer mate is the first person, he will be freed. Okay, his proposal is rejected, then the second proposal is accepted based upon the comparison. Okay, but when the first person is better, okay, he is 50,000, the second person is, you assume that he is getting 25,000, then if she feels first person is better than the second person, then she will retain this first proposal, she will reject the second proposal. So that is the response will given based upon this given criteria. That's what you see, simply say rejects M's proposal. That means a new proposal if the new person is not better than the previous person. So like this, again we have to keep on repeat this until there is free men available in the men's group, right? So here then we will check the second one, then we will check the third one. After completing this, we have to return that maximum matching pairs. Okay, so based upon this, the given problem is having three men, Bob, Jim and Tom. So here they are having three women and Leah, Shu, right? So Bob is having the first preference based upon the discussed criteria. Leah is his first preference, Anne is his second preference, Shu is his third preference. For Jim, Leah is first preference, Shu is second preference, Anne is third preference. For Tom, Shu is first preference, Leah is second preference, Anne is third preference. Likewise, women also having their own preferences. Anne is giving the first preference to the Jim, but here uh, Jim is giving first preference to Leah. You see difference. Okay, the Anne is giving second preference to Tom, the third preference to Bob. Leah is giving first preference to Tom, second preference to Bob, third preference to Jim. Shu is giving first preference to Jim, second preference to Tom, third preference to Bob. So based upon that, right, this both preference list will be given in the problem statement. Based upon that, we have to construct the ranking list, right? Ranking list means the preferences. Okay, so ranking list we are constructing using the matrix. So Bob, Jim, Tom, so both are given in the rows, then Anne, Leah, Shu in the given in the columns. So based upon that, now I am by finding the rank. So Bob is giving to Anne the second preference, so 2. Okay, first the first digit is mentioning the boys preferences, the second number is representing the women's preference. Okay, so the Bob is giving second preference to the Anne. At the same time, Anne is giving, okay, Anne is giving to the Bob third preference. You look at that, right? So third preference, like that. Next, Bob is giving to the Leah, right, first preference, right? The Bob is giving the Leah first preference. At the same time, Leah is giving to the Bob as a second preference, so that is written here. Like that, Bob is giving to the Shu third preference, so third 3 is written here. At the same time, Shu is giving to the Bob third preference. Okay, so she is also giving third preference. Then for the Jim, he is giving to the Anne as a third preference. Okay, so Jim is giving the Anne as a third preference, right? At the same time, Anne is giving first preference to the Jim, so 1 is written here. Then Jim is giving to the Leah first preference, right? 1. At the same time, Leah is giving to the Jim as a third preference, so third preference. Like that, here Jim is giving to the Shu as your second preference, so 2. Then at the same time, Shu is giving to the Jim as a first preference, so first preference. For the Tom, giving to Anne, okay, the third preference, 3 is written here. At the same time, Anne is giving to Tom as a second preference, okay, that is written here. So likewise, at the same time, Tom is giving to the Leah as a second preference. Okay, so 2 is written here. At the same time, Leah is giving to the Tom as a first preference, right? Likewise, Tom is giving to the Shu as a first preference. Okay, then at the same time, Shu is giving to the Tom as a second preference. So based upon that, we have to prepare the ranking matrix. So here we will start the proposal from the man. Okay, it is man oriented problem. So man is proposing the proposal to women. So as of now, we are assuming that all are free, men also free, women also free. Now Bob is the first person. He is sending the proposal to the first preference in his list. So for the Bob, Anne is second preference, first preference is Leah, Shu is third preference. So he is sending the proposal to Leah because she is in his first preference list. Okay, so as of now, Leah is free, so she should accept. So she is accepted. Then Bob is now matched with the Leah. Now Jim and Tom are free. Then now when you are coming to the Jim is sending the proposal, ready to send the proposal. Here first preference is here Leah, so he is sending the proposal to Leah. Now she is comparing her preference. Okay, so Leah is having second preference to the Bob, okay, third preference to the Jim. right? So Jim is not better than the Bob. So here Bob is second preference, Jim is here third preference to the Leah, right? So Bob is better than the newly coming proposal, Jim. So she is retaining his current mate. So she is simply rejecting the newly coming proposal, Jim, right? So that's what is written here. After that, after rejection of this one, Jim is having second preference is Shu. Shu is now free. Okay, so since Sue is free, then she is accepted the Jim's proposal. As of now, the Jim and Bob both are matched. Only the free man is Tom. Then Tom is sending the proposal based upon his ranking list. The first rank is to the Shoe, right? So here already Shoe is matched with the Jim. Now Shoe is checking her rank list. Rank list first person is Jim, okay, and second person is here Tom. So Tom is the newly incoming proposal. So this is already existing proposal. So existing person is better than the newly coming proposal. So she is rejecting the Tom's proposal. Once it is rejected, then he is approaching the second preference is here Leah. So when he is submitting the proposal to the Leah, then Leah is having her own ranking list. So already she was matched with the Bob. So Bob is the second preference to the Leah, right? But Tom is first preference to the Leah. So now the Tom is the new person proposing, right? So he is first preference list to the Leah. So then what she will do? She compares both, right? After comparing that, newly incoming proposal is better than the existing one. So she is rejecting the Bob's proposal, existing proposal, right? She is rejecting the Bob's proposal, accepting the Tom's proposal. That's what. So you see, Leah is replacing the Bob's proposal with Tom. So Tom's proposal is accepted by the Leah. As of now, you see, Tom's proposal is accepted and Bob's proposal is rejected. Okay, then now Bob is freed as per the after this iteration. So now Bob is freed. Then Bob is sending the proposal to his second rank. Okay, second wish list. Second wish list is here Anne. Anne is free. Okay, still she is free. So she is accepting his proposal Bob. So Anne is accepting the proposal of Bob. Right now, all men are engaged. That means matched. There is no man free. Okay, so all are engaged. So we can stop the algorithm here. So based upon this, here we can check the time complexity based upon the two for loops. One is for rows for men, okay, then columns for the girls, women, right? So two for loops we will use, outer for loop and inner for loop. So we will get n square number of iterations. The time complexity will be order of n square. Here the stable marriage matching is produced based upon the man oriented, that is called man optimal. Suppose if you want to change the problem into women oriented, the women can propose to the man first, right? So that we can do based upon the updation of the problem statement. So it can be used for medical graduates with hospitals for residency training. Okay, so this marriage, not only a marriage matching, we can use this problem statement for different applications. Thanks for watching.